Thanks, Laszlo. So welcome to the last slot of this conference. Great to see that not everybody has gone home yet. Still a few people there. So welcome to the talk about QSkinny, a new approach for a QtQuick framework. So this is not just the usual, we created another set of UI controls on top of QML or something. I hope I can convince you that there's a bit more to it. There's some layouting and theming things that we implemented. Let's see what we have. Just quickly before we start, who am I? I'm Peter Hartmann. I've been working on Qt since 2008. Previously, I was working a lot on Qt Network. I used to be the maintainer. Now I work a lot more on UI stuff, as is visible in this talk. You can find me on Twitter, so feel free to give me feedback or ask me questions. And since recently, I'm the founder of Edelhirsch Software, a company based in Munich dealing with Qt consultancy. So if you're interested in Skinny or Qt, feel free to let me know. Now, this talk has a classical structure, what, why, and how. But before we dive into that, let me show you an example. This is a UI written with QSkinny. Typical automotive UI. You see behind the steering wheel, there's the instrument cluster. In the center, and the top and in the bottom, there's an automotive UI on embedded Linux written with QSkinny on top of Qt. On the right, there's some Android tablet. Now, unfortunately, this UI is not public yet, so we cannot show you any details. Next week, there's this Agritechnica fair in Hanover where they're going to present the tractor, including the UI, and then we hope we can show you a lot more details on that. Just to show you that QSkinny is real, this is an example from the QSkinny repository. It's the automotive example with some speedometers. Yeah, well, you can resize it, have some theme changes, for instance. And I can also show you a screenshot. This is QSkinny running on Android. The Insta booth, at the booth area, they had this example. So this is written with QSkinny, and it's very similar to the automotive UI. Now back to the slides. Well, why am I showing you this anyhow? The point I'm trying to make is that QSkinny is not just a proof of concept or some tech preview or something. It has been used to implement a product that is going into mass production. So if you happen to buy one of these tractors, there's a Qt and QSkinny UI on production. So it's not just this, let's try it out and see how far we get. I mean, that's how we started with QSkinny, but it resulted in QSkinny being used really for a mass production product. So, why QSkinny? I mean, of course, the question that I hear a lot, okay, yeah, well, something with UI, why didn't you just use QML? Well, why QSkinny was created in the first place? There are some reasons, performance and memory usage. When QSkinny was created, that's some years ago already. I think the current Qt version was 5.3 or 5.4. And I think that was also the version where the V4 engine was implemented. Before that, the V8 was used from Google, and they created V4. So there were some performance issues with that in the beginning. It got a lot better. Also memory usage, also that got better. If you use a QML engine, I think it takes up several megabytes. Now that got better, especially if you use UI with multiple processes like a Wayland. Each UI process has a QML engine, which can not really be shared. Another reason why QSkinny was created was you have the freedom of choice between QML and C++. So QSkinny is written in C++, but the choice is not either or. So you can say, I choose QSkinny for parts of my UI, and the rest I implement on top of QML, because the elements created by QSkinny are just QtQuick items. The tractor UI that I just showed you, that's written in pure C++, so there's no QML involved, but that's not necessary. You can balance it the way you want. You can have your core components written in QSkinny, put some QML on top, or write everything in C++ with QSkinny, or just a thin layer of QSkinny, whatever you want. Now, the more important part of the why is like, why would you in the audience use QSkinny? For once, it has a public C++ API, as it's implemented in C++. It's usable from QML. As just said, you can put your QML on top, and it's LGPL version 2. Now, regarding the public C++ API, there is QtQuick controls too, which are implemented in C++. However, there's no real public API for it. So that class in C++, I think it's called QtQuick control. It's private, and it's used to implement a closed set of components. I mean, there's buttons, sliders, and a lot more, so it's already pretty complete. I think there's a table view since recently, but if you want to implement your own components, you're basically back to implementing everything in QML. And implementing things in QML can be perfectly fine, but might be that there's a bit more overhead involved. For instance, QtQuick controls 1, they were implemented completely in QML, and then the Qt company went on to create QtQuick controls 2, which are implemented partially in C++. But then again, you write your own controls, you cannot really interface to QtQuick controls 2, so you're back into writing everything in QML. QSkinny offers an API in C++ that you can use, and you might want to do that. And then again, mix and match with QML. Last point, it's LGPL version 2. The tractor UI is using Qt version 5.6, which was the last version which uses LGPL version 2, so everything is LGPL version 2. At some point, we might make QSkinny MIT or even BSD, that's not decided yet, but LGPL version 2 should be fine for now to just check it out. Okay, now I hope you know QSkinny is some C++ API using Qt in one way or another. What is it exactly? Just show you some diagram here. I hope this is readable. In one sentence, QSkinny is a lightweight framework on top of the Qt scene graph, or it should actually say on top of QtQuick, because all the elements, the UI elements of Skinny are actually QtQuick items. So you can see on the top left corner, if you write your UI with Skinny, you say auto button equals new QSK push button. That QSK push button is indirectly a QtQuick item. Yeah, those QtQuick items that you see on the left, they are used by the scene graph renderer and displayed somehow. So for each QtQuick item, there's one or many nodes created, like you have a rectangle for a button and all these kind of things. And that stuff is rendered. And then you have the hardware backend underneath. For now, it says OpenGL, but of course, as Laszlo told us yesterday, there's more backends now implemented. There's Vulkan and Metal and Direct3D. So, but that's can be reused by QSkinny. QSkinny sits on top of QtQuick and is reusing those components. Now in the middle, you see your QML interface that you probably know. You write your QML UI in those declarative syntax, and the QML engine takes that and creates QtQuick items. For instance, for every rectangle you write in QML, there's a QtQuick rectangle created on the QtQuick layer. So you have this translation step. If you use QSkinny, there's no interpreter or no engine involved, and it creates those elements basically directly. Now, in contrast to the new graphics stack with QtQuick and the scene graph, you see on the right the old widgets. On the top right, you see this box saying auto button equals QPush button. That looks very similar to the QSkinny side. But underneath, you have Qt widgets and the paint engine. Here, there's the raster paint engine. There's also more. There's the X11 paint engine, for instance. And that will be broken down in the Painter API to draw rectangle and draw text and those calls. And that's all rendered in software. So you could say QSkinny is similar to QML in a way that it's using the modern graphics stack, QtQuick and the scene graph and so on. And it's also somehow similar to Qt widgets in that it's having a very similar API. But of course, the controls that are implemented in QSkinny are not the same ones that are used in widgets. I mean, of course, there's also buttons and labels, but there's different things. And to be honest, QSkinny doesn't have that many controls as widgets yet. Yes, so to give you a bit more of an example, this is a simple hello world-ish code with QSkinny. I'll give you a bit of time to read. So yeah, I guess, and I hope this is somewhat unsurprising. You create a button, you create a label, you create a box, which is, in QWidgets, I think it's called a layout, vertical box, so you stack them on top of each other. You add the items to the layout, and then you create a QSK window, which is a quick window, and then you show them. And that's it. So that's, maybe if you used QtWidgets before, that might remind you to the good old times of QtWidgets, or whatever you want to call them. So yeah, now to dig a little deeper, how does QSkinny work? Remember when I said that QSkinny is more than just a set of UI controls? There are some concepts implemented that distinguish it a bit. For instance, one thing is the separation of implementation and styling. You can see here the class view of things. Imagine you have your UI controls, buttons here. Those buttons have so-called skinlets, which are responsible for drawing. So they are somewhat similar to delegates in QML. You have your buttons, and when it's time to draw them, the skinlet takes care of drawing them. So you have a skinlet for a button, for a label, for a slider, and for all UI controls. And all those skinlets are part of one skin. You could think of a skin as a theme, like a dark theme or a light theme that you can switch, or also like a brand theme where you want your UI to look differently depending on the branding. Now let me show you, I think I showed you already, this example of the speedometers. You can switch, and you can even interpolate between the colors, depending on the type of animation. You can see here that the handles change a bit. What this example does not show, that you can exchange the skinlet at runtime completely. So imagine you have a checkbox, and you have in widget style, you would have this white background with a black tick mark, and that you can make it check or unchecked. But for a mobile use case, you could implement this completely differently. You could have like this sort of slider that you switch on and off. And that's actually no problem in Skinny. You just exchange the skinlet at runtime, and then you just draw it completely differently. Interestingly, from what I hear, the Qt company is interested in having some sort of styling in C++. So they're thinking of some similar concepts. I'm not sure how far they are or how much they're interested in that, but this is already working and might be interesting to check out. Now, the same use case, if you look at this from more like a flow diagram, it works like this. So there's the renderer on the top left, which is the scene graph renderer, which at some point just says, draw your stuff. The button is implementing update paint node. That's actually a virtual method from QtQuick item. And then it tells the skinlet, okay, draw your stuff. And the skinlet draws the nodes from the scene graph. If you remember the diagram, that was one level below QtQuick was this scene graph node, and it just creates the nodes. So in the case of a button here, you could have a panel, like a background rectangle. You could have a graphic if the button has an icon, and then it could have a text for the button text. Yes. Now let's look a bit more detailed into an example. Page indicator. That's still not very impressive yet. It's just one component. You can see a screenshot. I mean, the colorful buttons are just Mac window decoration, so please disregard them. You see those 5 bullets, and maybe you know from your mobile UI you have different pages where you can swipe, and the page indicator will show you which is your current page. Unfortunately, here you cannot really see the current page because the styling has not been implemented, but well, in the API, you can see we create a page indicator, we set the current index to 0, and then we set the count to 5, meaning we have like five pages, and the page indicator is supposed to show us which page we have. Again, so far so unsurprising, I guess. You can see in the bottom part of the code, internal. That's of course very simplified. You go through all the nodes that you want to draw. In this case, we have 5, and you create a box node, which is a scene graph node for each of the bullets. And of course, those nodes will be reused. The first time you draw them, you create the new nodes, but of course, when you update them because there's a layout or size change, then you of course reuse the nodes and just replace them. Now, the interesting thing about this is how this looks on a scene graph. This page indicator is one QtQuick item, and the rest is just scene graph nodes. So it looks a bit like this. I just went ahead and dumped all the nodes that are created. So the top 2 nodes, the root and the QtQuick root item nodes, are just from the QtQuick window. So they're not really part of the page indicator, they're just always there. It starts with the page indicator. So each QtQuick item has a transform node. Transform node is there to place the element on the screen, like you have an X and Y, and I think you can also add rotation and all those kind of things. Here we just have X and Y. Then you have 2 helper nodes that are used just to group, make it easier to draw the stuff. And on the bottom, the pink ones, these are the 5 bullets. Because remember, we had 5 items on our page indicator. So these are 5 bullets plus 6, 7, 8. 8 nodes for the page indicator. Now, let's see how this works for QML. There's a page indicator element in QtQuick controls 2. Looks like you can see on the right. We set the current index to 0 and the count to 5. It looks very similar. Internally, that's code from QtQuick controls 2. You create a page indicator, and as a delegate, you have a rectangle, meaning you have a model with 5 elements, and then the delegate has rectangles. So for each instance of the delegate, you create a rectangle. That's how QML works. And each element in your QML is a QtQuick item. So the rectangle, again, for each is a QtQuick item. So you have 5 QtQuick items. So if we look at how this is drawn on the scene graph, it looks like this. Again, the top 2 nodes are from the QtQuick window. It starts with the third from the top, the QtQuick page indicator. That's our main component. And then, as you can see, there are more QtQuick items involved. There's a repeater, a QtQuick row, and then each instance of the delegate is again a QtQuick item, so you have a transform node for each of them. Apparently it's implemented with opacity, so you also have opacity nodes for each instance of the delegate. And then you have, again, the geometry node for actually drawing the bullet. So these are 15, 16, 17, 18 scene graph nodes in this case, so it's a bit more than QSkinny. Well, of course, a page indicator you probably only have once per application, and a few more scene graph nodes doesn't really stop the world. It's not that bad, but sometimes if you have a complicated control, you might want to have more fine-grained access over how you create your scene graph nodes and how many. Sometimes if your UI is pretty complicated, and for the tractor UI it was it's very technical, the UI, so you have to implement a lot of controls yourself, and then sometimes you want full control over how you draw your things and how you cache your scene graph nodes. Yeah. It might not be a problem, but it could, and then it's nice to have a lower level control. Yeah, so I'm already coming to the last slide, which is thanks. Feel free to check out the repository. It's on GitHub. The example that I showed you, this one, it's there. It's the automotive example. The slides are also in my GitHub page, and then feel free to contact us in the email addresses. This is mine and the one from QSkinny. Yeah. Feel free to let us know if you're interested, if you want to try it out, or if you tried it out and have some feedback. There's also a possibility to create merge requests. For now, I have to say, QSkinny, as I said, is used in production, but it's mostly tied to this tractor project that we're using it for. So all the controls we've implemented are really the ones that we needed for this project. So it's not that generic purpose yet. But if you want something implemented or interested, feel free to let us know. We're happy to look into it.
All right, thank you, Peter. So now there's time for questions. So questions?
Hi, how does this interact with scene graph batching or with batching of drawing? Does it just work, or do you have to do some integration?
We didn't do much integration. Let's see. Here, this is this overdraw mode. Well, I don't have a list view example at hand, but if you have a list, then it's being batched as well. Actually, I don't know how the internals work, but we didn't really look into it because it seemed to work good enough for now.
All right, thank you.
Yes, more questions?
This one.
I've been following the repository for a while, and one thing is I don't see any releases. Do you plan to make some stable branch or?
Yes, I think that's the plan. There's Uwe Hartmann, who is the creator of QSkinny. I think he's planning to do some release. For now, they're busy with the release of this tractor thing, but I think the long-term goal is to make some release and then see how it goes with adding. It probably won't be as strict as Qt with all the binary compatibility, but sure, we try to. I mean, one goal is to have some controls. For instance, these speedometers that you can see here, they're just part of the example. And then maybe if the API is stable, we can promote them to QSK controls and then leave it as stable as it is and then try to change a little. So I think the details are not really figured out yet, but of course, yeah. Midterm goal is to really have releases for it and then use that.
And another one is, given that for some stuff there is no public API, how do you deal with that? Like, for example, for text rendering, I don't know if it has changed in the last year or 2 years, but there was only private API.
Yeah, in some parts we include private API from QtQuick, which in practice is not a big problem because it hasn't been changing that much. That QtQuick part is pretty stable, so we include private API in some cases, but which is not ideal, but yeah, hasn't been a big problem so far.
All right, anything else? Yeah, if there are no more questions, then thank you again.
Thanks as well.